Hi everybody, solving paper 4 version 2 June 24. Load suspended from a thread, vertical force on thread is calculate mass as the vertical force is the weight of the load, so we can find the mass from the relation W equals M times G. We substitute the weight and G 9.8 or 10 and find the mass. A wire is attached to load at X and pulled horizontally to right. Tension is, by drawing or calculation, find magnitude of resultant force at X and its direction. We'll use the Pythagoras theorem, where the resultant force F is the vector that closes the triangle formed by the weight downward and the tension to right. So its length is square root of both the squares of the two sides, or you can use the rule to make a scale, for example 0.5 Newton to be represented by 1 centimeter, and then draw 0.75 and 1.2 to the scale. After that, measure the length of the vector that represents the result. But we will, as I said, use the calculation and Pythagoras theorem to find the direction. Tan theta is the opposite to the neighbor, so we can find theta, but theta here is the angle relative to the horizontal. We need the angle relative to the vertical, so we need this angle. It is 90 minus 23, the angle to horizontal. Force produces changes in size and shape, state to other changes, change in speed or direction of motion. Define acceleration, rate of change of velocity. Train has mass of and accelerates at calculate time to increase its speed from 15 to 28 meter per second. A is equal to delta V over delta T equals 28 minus 15, the change in velocity over A. Okay. Calculate force required to produce acceleration. We know that force equals mass times acceleration, so we substitute and find the answer. Train uses electric motors. Explain why force on train due to motors is greater than value calculated. So this is because train manufacturers take into account that additional force is required to overcome friction and resistance. So if they made motors that just provide the force of the mass being accelerated with the targeted acceleration, it will be less than this acceleration because this force is subtracted by the opposing force of friction and air resistance. Student drops heavy ball from vertical height of ball, then falls to ground, doesn't bounce. Describe energy transfer. So energy transfers from gravitational potential energy store to kinetic energy store as the ball is falling, and after it hits the ground, all of its kinetic energy is transferred to internal energy store, and you can see also the elastic potential energy store as the ball is certainly will, uh, will certainly be deformed. Okay, and surely internal energy can be transferred in form of thermal energy. Calculate maximum speed. So we know kinetic energy is equal to gravitational potential energy because all of gravitational potential energy is transferred to kinetic energy stored, and the gravitational potential energy is given by mgh, so it is m 9.8 or 10 times 1.8. We don't have m, so we'll leave it as it is. Kinetic energy is half mv squared, so we can equate this term by this term, and we can eliminate the mass and do the rearrangement and find velocity. Stateways evaporation differs from boiling, no bubbles in evaporation, and it occurs at any temperature. It is not necessary to reach the boiling point. Here is a container, contains a mixture of liquid gases. Temperature of liquid oxygen is minus 160. Determine temperature of it in Kelvin. Temperature in Kelvin equals the 10 Celsius plus 273. So by making calculation, we obtain it in Kelvin. Container is made of steel. There is a vacuum between inner and outer walls. Outer wall is at room temperature. State two methods of thermal energy transfer that a vacuum prevents. First one is convection because there is no air, so there will not be air current. And second one is conduction because there is no medium to allow the atoms and free electrons to transfer the energy from a hot end to cool end, so on. Describe in terms of particles how gas exerts pressure on wall of container. Particles have kinetic energy, so they make collision with walls, and collision makes change in momentum. Change in momentum causes force because force is delta mv or delta b, delta change in momentum over delta t. And certainly pressure is force divided by area. There is a yellow light incident on a glass prism. Explain why rays doesn't change the direction or doesn't refract when it enters prism at AB, because it enters normal or perpendicular to AB. Critical angle 42. Calculate N 1 over sine C 1.5. Continue path of light through prism and after it leaves the prism. So through prism it will incident on BC. So we will use the protractor to measure this angle, and if this angle, which is I, is greater than C, we will have total internal reflection. If it is less than C, we will have refraction at BC, and if it is equal to C, we will have ray refracted ray normal, tangent to BC. So when you measure it with the protractor, you will find it as around 58 degrees. So it is greater than C, which was 42. So it will be totally internally reflected, and there will not be any reflection at the interface BC. After it is totally reflected inside the glass, it will incident on AC, and this angle is 90, so it will pass without any refraction. at AC. Internet data can be transferred using infrared waves in optical fiber. See two advantages of optical fiber. It is faster in transmitting data, carrying a large amount of data, have less loss in signal current. Here is sound wave represented by pressure time graph label C for compression and R for refraction. It is something confusing when you see the sinusoidal wave, which uh, more likely to the transverse wave. You see it to represent the longitudinal or sound wave. It is really confusing, I know, but if you imagine a spring that is attached to a mass at rest, and then you give this mass a displacement to to left from the equilibrium position and leave it. What happens is it goes as far as these springs allow to lift, and after that it begins to return to the equilibrium or rest position. Here is the rest position where the spring has its normal or original length. So when you start from zero, from rest position, you reach the maximum of compression which the spring can bear, and after that the spring will start to return to the rest. Okay, so the spring will be still compressed until it reaches the rest again. Although the compression decreases, okay, as it moves to rest again. So the peak here represent compression, and when it reaches the rest again, the compression ends and the mass started to move to right, where the spring is stretched and continues to right until it reaches the maximum stretching. So this is represented by the trough. Start from rest, increase in length of the spring or in the uh, displacement, or increase in pressure but in negative pressure until it reaches the maximum. Then it starts to return back to the rest position. So stretching still exists, although it decreases until it reaches the rest again. You can make the analogy to particles of medium where they represent a spring, okay? And this spring, for some reason, has compression in some areas, like the situation where we compressed the spring, and in other areas it has stretching, okay? Then you will find this graph is reasonable and you can understand the answer of having compression in peak and R in trough. Explain why graph cannot be used to find wavelengths of sound wave. Because to find wavelengths we need to have the distance on the x-axis, the distance through which the wave moves or cover But as we have here time, we cannot find the wave length. We can only find the periodic time or frequency. Periodic time is certainly the time of one wave. Sound become louder and lower pitch. Amplitude increases because amplitude is loudness. Frequency decreases because it is pitch. The frequency and the speed in water given. Calculate wavelengths. V equals lambda F. Lambda equals V, which is meter per second, over F, which is in kilohertz, and we will convert it to hertz to have the distance in meter. State approximate speed of sound of air is 330. 3 bars of steel, ABC. 2 of them are magnetized, 1 is unmagnetized. Describe and explain how to determine the unmagnetized one using only the 3 pieces of steel. So if we approached A to B and both of them are magnetized, we approached them by, for example, approaching A from one end to B and or approaching approaching A from the other end to B, and we found that in any of these two cases there is a repulsion with B, so it is certainly magnetized. Because magnetized steel piece means that we have north pole and south pole. Okay, but unmagnetized means that we have induced magnetization when we approach a magnetized piece. So we can firstly use A, approaching it to B from both of the two ends of A, or the two ends of A. Okay, if we have repulsion with B, so both A and B are certainly the magnetized pieces and C is the unmagnetized. If we haven't a repulsion, and when we approach A from most of its end to B, we have attraction in the two cases. I mean the case approaching A from right or approaching A from left to B, we have attraction in both cases. So either A or B is unmagnetized. We can use A to repeat the same with the C and judge whether we have repulsion or not. If we have, and we will surely have, because if B is if one of A or B is unmagnetized, so we have the other one magnetized and the third one certainly magnetized, so we can exclude the third one as a magnetized and then think about how to use the third one to figure whether A or B is the magnetized one. Think about it in light of what I have shown here and in what I have written as the answer. You can pause the video and read this answer carefully and uh, express it in your way. Okay, here's the step down transformer. Mains voltage 240, output power 45. Transformer is 100% efficient. Calculate input current. Efficiency equal useful output power over input power times 100, and putting the percent, or we can remove all of this and only write it in a 0 point some number. So 100% means 1, and we substitute the output here by 45, and here is the input is 45 too, and input power is I input times V input. V input is given by means voltage is connected to the primary coil. So we have current to be 45 over 240. Label step down transformer and state suitable material for each component. As we know, coils from copper and core from soft iron. Circuit is designed to switch on a night light. Night light means that light that uh, lamps that lights off when sorry that lights on when night starts or after the day. We found that some lamps are automatically switched on. Here is the circuit where we have light dependent resistor. This light dependent resistor should have the low resistance in dark surroundings to it should has a high resistance in dark surroundings because the lamp that will light on is a light emitting diode. If we don't have the light emitting diode connected in parallel here, and we have some lamp connected here, so I will say that this light dependent diode should have low resistance at dark, but as the lamp is LED and connected in parallel to LDR, so we should have a high resistance here because as we see light dependent resistor is connected in series with a passive resistor, so potential difference of the supply is shared between the two. If we want light emitting diode to be light on with uh, uh, large luminances, we should have high potential difference across its terminal or high potential difference across the LDR because it's connected with LED in parallel, and as we know, connection in parallel means same voltage or same potential difference. Okay. Draw circuit diagram for a voltmeter as I did here to measure potential difference of LDR should be connected in parallel. Always voltmeter should be connected in parallel and the ammeter should always be connected in series. Surrounding changes from light to dark, as we have just explained. The effect of this change on resistance of LDR should be an increase in resistance of LDR. State and explain effect of this change on potential difference across LED. As also we have just said, potential difference increases as it is connected in parallel with LDR, through which potential difference also increases, because same for parallel connection. And we should also mention that supply voltage is divided between resistor of LDR and the passive resistor. Here is another circuit. A and B are identical. Current supplied by a power supply is 0.5 ampere. Calculate resistance of lamp A. So we have Ohm's law V equals IR. And as we have the current through the circuit 0.5, we should find the equivalent resistance of the two. And this equivalent resistance is V over I. V is given 240 over I 0.5. So we have equivalent resistance of the whole circuit 480 ohm. And this equivalent resistance is equal to RARB over RA plus RB, because they are connected in parallel, okay? Or it is equal to RA over 2, because RA and RB are identical. So we can equate this term by 480 and find RA. Radioactive isotope that emit ionizing radiation are used in hospitals. State and explain two safety precautions for using these isotopes in medical procedures. Reduce exposure time to reduce the amount of radiation absorbed by humans. Use lead boxes and gloves or shield to avoid most of radiation penetrating your body. Give two reasons why alpha emitter aren't used as radioactive tracers in body, because they have low penetration, so cannot penetrate the body to detector, and it has high ionizing power, so more harmful to body tissue. Sodium 24 isotope of sodium has 11 proton and nucleon number of 24. It decays by beta to magnesium. Right nuclide notion. So here is the sodium 1124, here is the magnesium. We don't know its proton and nucleon number, but we know that beta combined has -1 atomic number and 0 mass number, so this should have 12 to add both of them and have 11, and it should have 24 because addition of both nucleon number here should equal to the nucleon number on left. Solar system includes the sun and planets, two other types of natural objects that orbit sun, comets and asteroids. State shape of orbits elliptical. At point B, object is furthest away from sun. State and explain energy transfer as object travels from A the nearest to B the furthest. It is kinetic energy maximum at A that converts to gravitational potential energy, which is maximum at B. So kinetic energy here is maximum and potential energy is minimum, but the situation is reversed in the other side. Okay, because as I said that kinetic energy store transfer its energy to potential energy store as we goes away from the sun, and because energy is conserved. Jupiter has this distance from sun, and speed of light in vacuum is given. Calculate time. It is a regular V equals d over t problem, where we can write that t equals d over v, okay, and we can find the answer easily. Name galaxies that contain sun. It is Milky Way. Light observed from distant galaxies is redshifted. Set theory of universes that this observation support. It is the Big Bang, which means that the universe was just a point called singularity. I see it in the next question answer. And this singularity or this point started to expand from the moment of universe initiation. Cosmic microwave background radiation is observed at all points in space. State when this radiation was produced. It has been produced shortly after singularity start to expand. Explain why this radiation is now in microwave region of EM spectrum because it is redshifted or wavelengths increases as universe continue to expand. This is all. Thank you for watching and waiting for you in next video.